So Unit 4, Lesson 5, so multiplication of rational numbers. So the first thing we're going to do real quick is that we're going to just talk about multiplication of fractions, just so we remember. Like I was explaining earlier, multiplication of fractions is probably the easiest fraction operation to do. So, I mean, just real quick, remember when you're multiplying in fractions, you're just going to multiply straight across. So you're going to go 7. Okay, you got your 7 times, and your 7 times 1, your 10 times 5. Okay, straight across. And then you have your 9 times 5 and your 10 times 6. Okay. So hopefully that's not new to you. So 7 times 1, we get 7. 10 times 5, we get 50. That can't simplify anymore, so we just leave it that way. 9 times 5 is 45. 10 times 6 is 60. You have a common denominator, or excuse me, a common factor of 15, which makes this 3/4. If you know the cross cancel way, absolutely, you can do that as well. Okay. But there you go. So 3/4. Okay. What's important here, and again today it's going to pull on stuff you already know. Okay. You know that when you're doing division and you have exponents in terms of a fraction or division, what's the rule for division of exponents? Comes from Math10 and 9. Subtract them, right? You minus the exponents, okay? Let's get a quick refresh on that. If you have 3 cubed over 3 squared, that means you have 3 3s and 2 3s. They cancel, you're left with 1, which is 3 minus 2. 3 minus 2 is 1. That's where it comes from. Okay, that's kind of the definition of division. So the reason I'm telling you that is, okay, so see how this is multiplication, right? Well, since this is multiplication, let's put the top together and the bottom together. Okay, and when you don't have, okay, when you don't have, come on, Spencer, figure it out, bud.
I put it on silent.
Well, it's not on silent. Okay, let's get back on track here. Okay, so 12 times 3 is 36. X times x is x squared. Y times, there's no other y, so it stays y. Z squared, there's no other z, it stays z squared. Now, what's really important here, and I really believe this, is that as you do these things, there's a lot going on. I'd kind of cross things off. Leave me with your pencil or to yourself. Okay, kind of here. I did the x's, I did the y, and I did the z squared. So I've done all of it. Okay, I've done all of it. Yeah. Yeah. Yep. Okay, and add the variables. You add the exponents.
Yeah, so say if you had like x squared, what would you do? So like
It'd be x cubed. You add exponents when you're multiplying.
yeah, okay.
Just add the exponents if you're multiplying. Okay, you'll see. Okay, this one here, 4z and y, I can't do anything with those other than just put them together. So this is where I'm at now. Now we're going to do the division part. Okay, 36 over 4 is what? 9. Good. x2, there's no x's, so it stays x2. Y over y cancels. z2 over z1 is z. Or z, sorry. Okay, there is your simplest part, your simplest simplification, I guess the best way to put it. Okay. All right, we good? Okay, so now this one. Now, sometimes it can be easier to simplify the pieces first and then multiply. If you want to always just get it all together and then multiply, and simplify, that's fine as well. I think with this one, it might be easier, since 5 are going to 14, I could probably just multiply across, which is fine. So this is what you're talking about, Spencer. So I have a B2 times a B, that's a B1, so 2 plus 1 is B3. Okay, 5 times 35 is 175. A squared B3, C4. That's my top. 14 times 40, is that 560 maybe? Yeah. 560. B2, there's no B over here, so it stays B2. C and a C makes a C2. There's a D and then an A3. Order doesn't matter. I know you probably want to write it A, B, C, but it doesn't matter. Okay, so we can simplify this. 5 probably goes into both of them. So what's 5/16? Okay, perfect. So 5 over 16. Okay, I have an A2 over an A3. So what's 2 minus 3? What's 2 what's that mean? Good. A's on the bottom. So that's good. That's done. I did that. We did that. B3 over B2. So 3 minus 2 is 1. So I have a 1B on top. And then a C4 over C2 gives me a C2 on top. And lastly, this D is just left where it was. So you have 15 BC squared over 16 AD. That's the simplification. Yeah, Zach? The exponent? Yep. Anytime you get a negative by doing that subtraction, that means it's on the bottom, if it's negative. Any questions on that there? Okay, we only got a couple more examples. So, all right, so now we're talking about with the rational expressions, because that's what we're doing. So we're going to simplify, state the restrictions on the variable. We're supposed to do that up top too, weren't we? We'll do it here. Okay, so first let's do the restrictions because it's already factored. So x can't be x can't be 2, -3, -1, and 0. Those are my 4 can't haves. 2, -3, 1, and 0. Okay, now this is where I feel like this makes multiplication really easy. I always, if it's multiplication here, I just pretend this is all one bar. And I just have all these multiplied together. Because then I can see right now that my x plus 1s will cancel, my x plus 3s will cancel, and I'm done. That's it. So what I'm going to have now is 2 on top, x minus 2, and x on bottom. And that's your answer. Any issues with that or questions? So will you believe in me that it's easier maybe? Okay, so then what do you think we want to do on B though? What do we want to do first here on B? Yeah, we want a GCF first. Whenever you don't see stuff, nice little products like that, we want to get them like that. So I'm going to take a 4 out here. I'm going to take out a 7 here. So that's going to give me 4 times x plus 4 times, I'll push that 2x minus 1. I like to put them all in one fraction, so I just put these together. That takes a 7 out, gives me 2x minus 1, and then I have an x plus 4 squared. Okay. So the 2x minus 1's cancel. We'll do the restrictions here in a second. Okay, I have an x plus 4 on the bottom, and then I have x plus 4 squared, x plus 4 on top, x plus 4 squared on the bottom. What does that mean? We leave 1 on the bottom. This is like a 1 minus a 2. 1 minus 2 is a -1, leaving 1 of these on the bottom. So our simplified answer is going to be 4 over 7x plus 4. Okay, let's go back to this piece right here, and let's do our restrictions. Our restrictions on what x can't be. So what is the first one? Sam, what's this one? For what x can't be? 1/2, good. And then Kyle, what's the second one? -4. Okay, good. 1/2, -4. Okay, just a little bit left here. Just got some a little bit uglier problems. Okay, so now they're making you factor a bunch. This is the only part again. But again, it's not new. I really like to, when I'm doing these problems, I really like to section them. Top left, top right, bottom right. Just factor them individually. They're like 4 little separate problems. I think the only complaint about this unit is stuff takes a long time. Okay, so this, I can take a 2m out. So I'm just going to work on factoring this one first. So my one spot, it's going to be 2m comes out. I have an m squared minus, I want to take an m squared out, don't I? Excuse me, I want to take an m squared out. So that gives me m minus 2. So my top's factored, number 1. Now we're going to do the bottom real quick. Call it number 2. Okay, that factors, I can take a 3m out. M minus 3. Good. Come over here for 3. 3 factors to, what's that factor to? Inspection. Close, negative, yep. Negative 3, positive 2. And number 4, factors, different squares, m plus 2, m minus 2. Okay, so we have everything factored now. Now essentially, the way I've already kind of written it, it's just this stuff's on top, this stuff's on bottom, right? I'll write a little bit cleaner for you. So if I write cleaner, it'd be 2m squared, m minus 2, m minus 3, m plus 2. So on top, my bottom, 3m, m minus 3, m plus 2, m minus 2. Okay, now we're just playing the cancel game here. Do I have m minus 2 top and bottom? Yep. M minus 3? Yep. M plus 2? Yep. All my binomials are gone. What does 2m squared over 3m cancel to? Good, yeah, the m cancels off. This one's changed to 1, so it's 2m over 3 is what all this stuff turned into. Okay, let's do our restrictions real quick. Our restrictions are going to come from this piece right here. All right, so Davin, give me one thing that m can't be from the bottom there. 3, good. So she did this one. Okay, what's something else, Zach, that m can't be? Sure, 2. So that one, you did this one. Okay, Quinn? Negative 2. And what's the last one? James, you know the last one? From this guy right here. What is 0? Okay, remember the first one's got to be 0. Okay. All right, last example here. Pretty big. Okay, so we have, it's back to the top, back to the bottom, so let's have you guys kind of help me with this one. So the first piece, okay, Lauren, what's number top left factored? What is it? 5 and 3, so a plus 5, a plus 3. Okay, Emma, what's below that factored? You probably have a little bit of work to do for this one. No, I said Emma. Yeah, the bottom here. So you have to do, you're going to have to pull out a 3, and then you're going to have to do decomp. So go ahead and do that. I'll come back. Okay, let's do part 3, the top here. Well, that's just GCF, so what can that GCF to? Connor, what do you think? So you can pull out an A? And that makes 1 minus 4a squared. Can I do anything with that? 1 minus 4a squared?
1 minus 2a, 1 plus 2a.
Yep. So 1 minus 2a, 1 plus 2a with the a in front. So that's what our top right's going to be. Okay. I'll do the bottom right, and then we'll see if Emma's ready. Okay, so 2 times negative 5 is negative 10. So factors negative 10 to get me 9 would be 10 and negative 1. Okay, so that's going to give me 2a squared plus 10a minus a minus 5. Group. 2a comes out. A plus 5. Take a negative 1 out. A plus 5. Okay, so number 4 factors down to 2a minus 1, a plus 5. All right. Emma, do you have the other part? 6 and 1. Okay, 6 and 1, so 3 times 2a squared plus 6a plus 1a plus 3, okay? Okay, so 3 times 2a is a plus 3. And then what'd you take out there? Just a 1. Okay, so she got, for the one, 3 times 2a plus 1 and a plus 3. All right, so I know it's kind of all over the place. That's the difficult part of these problems, but here's one of our regions. Here's the other part of our regions. We have this guy and this guy. Those are our 4 pieces. So I'm going to have, whoa, gotta get off highlighter mode. All right, so I'm going to have a plus 5, a plus 3, all over 3 times 2a plus 1, a plus 3, and then I'm just going to put it all together because we know it's multiplied. That's multiplied right there. There's nothing there. That means they're multiplying. So I'm going to put another a right here. 1 minus 2a, 1 plus 2a. And then I have 2a minus 1 and a plus 5. All right. Now let's get this thing simplified. Now let's do our permissibles first. A can't be. All right. What, Eli, what's this one? Negative half, good. Sarah, what's this one? This one? Negative 3. So you haven't called on yet. Talia, what's this one? 1/2, good. And let's see. Gabby, you can do this one. What's the opposite of positive 5? You got it. What's the opposite of positive 5? Negative 5. All right, so there's your non-permissibles. Good. All right, so now it's canceled. So I have a plus 5s that go away. I have a plus 3s that go away. Okay, is 2a plus 1 and 1 plus 2a the same thing? Okay, so those go away. All right, and we learned this in lesson 2. What can we do here? Yeah, take out a negative 1. So let's pause so we don't skip this step. So we have a times 1 minus 2a all over 3 times 2a minus 1. So if I take a negative 1 out of here, it's going to flip it to look like this, which just makes me have a negative a out front. So it's going to be negative a times 2a minus 1. I just flipped it around because I took a negative out, over 3, like that. Now this is the only way you can do this. Only way you can do this if they're exactly the opposite. So this one had a what? A positive 1. What's this one have? Negative 1. This had a negative 2a. What's this one have? Positive. See how they're exactly the opposite? Sometimes they're not. So make sure they're both exactly the opposite. Okay, so now this cancels, and you're left with, from all that ruckus up there, you're down to negative a over 3. Right. Or just a negative somewhere, but yeah. Okay, we are good. All right, that's it.